Hi, everybody. Welcome to Bitcoin Script, where we're going to learn how to program in Bitcoin Script. Everybody ready? Yeah! Let's get to it. All right. So first thing you might want to do is follow along. And so I've pulled this up. You can visit this URL, and if you do, you'll get a copy of this whole presentation. That I recommend it because, like with the last workshop we did, there's going to be some live coding. You're going to be like copy pasting things and doing programming, and it's helpful to be able to have the page up that you're going to copy paste stuff off of. Also, my GitHub is on here, and if I show you that, this page has a link to the slideshow as well as a link to what we're going to build. This is it. Isn't that beautiful? Isn't that gorgeous? If you inspect the console, it does a few things. It creates a pub key for someone named Alice. It creates a pub key for someone named Bob. Creates a smart contract Bitcoin address, and then it gives you this, which is a transaction that spends money out of this smart contract. But we're going to show you, I'm going to show you more about what all that does as we get to it. But that's what we're going to build, and then you're going to like modify this and make it your own. By the way, last time I did not go over this, is how to bring up this little sidebar. In most browsers, you can right click and say inspect or like developer console or something like that, and it'll show you this sidebar. Then you click console. If yours doesn't do that, you might be able to get it by going to more tools, web dev tools. So that's another way to do it, at least in Firefox. But yeah, that is what we're going to be building today. Another thing is there's an IDE that I find really helpful for writing script in. It's called Scriptwiz, and this is what it looks like. So you might pull that up at some point when it or have it available so you can write scripts in it. Next thing you're going to need to do is download Bitcoin Core. This is going to be different on different operating systems. So if you have Windows, this might work differently. But here I'm using a Linux device, so I'm going to save the Linux version. Go into my terminal. I know this part's hard to follow. Sorry, guys. There's no good instructions for this. I'm going to unzip. In Linux, we use tar usually instead of zip and unzip, but I'm going to unzip that file I just downloaded. So did that. I'm going to remove the zip file or the tar file. It's equivalent to zip. And I'm going to go into the Bitcoin 23 folder. And in here, there is a bin folder, which has the actual program in it. So that is how you download Bitcoin Core. I hope everyone was kind of able to follow that. It's going to be a little bit different on Windows how to do this, but that you need it. So if you need help, it's important that you're like, hey, I need help getting Bitcoin Core on my machine. The other thing we're going to need to do when we run Bitcoin Core, we're going to run it in reg test mode. Reg test gives you a little test net on your computer, a test network that's like a copy of the Bitcoin network, except it starts at block 0 and you can do stuff with it. That's important. I always do stuff on the test net before I do it on the real network. And that's what we're going to be working in. So once again, in Windows, starting things in reg test is going to be a little different. I think you have to modify the icon that you double click. So if you need help with that, raise your hand. You gotta have this ready. So if, like, don't be like, well, I'm going to be quiet because I don't want to call attention to myself. Call attention to yourself. This is the time to do it. Anyone need help getting set up? Okay. Then I'm going to run Bitcoin QT in here. And great. It wants to know where I want to save my stuff. I'll save it right there. And it's telling me I have Bitcoin Core running in reg test mode. Create a new wallet. I'm going to call it test wallet. And make sure you uncheck descriptor. It can't be a descriptor wallet. It has to be a regular one. I don't even know what descriptor wallets do. I haven't learned it yet. But a consequence of using descriptor wallets is that it doesn't show you your private key when you ask for it. And we may need those. Okay, it's an HD wallet. Yeah, so now we should all be set up and ready to go. Let's learn about Bitcoin Script. before we're going to get into using Bitcoin Core and the programming stuff in a minute, but first I'm going to give a short lecture on what Bitcoin Script is. Bitcoin Script is a programming language, and yeah, it's built right into Bitcoin. It comes with every copy of Bitcoin, comes with your Bitcoin wallet. It's all in there. It uses locking scripts and unlocking scripts to control the flow of money, and these scripts are made of text. A lot of people assume, because this is how user interfaces portray it, that Bitcoin works like this. This is Bob over here. He has a Bitcoin. He wants to send it to Alice, and so she's got a wallet. So he just, bloop, money goes straight into our wallet, and we're good. That's how we try to present it to users to make it make sense, but that's not actually how Bitcoin Script works. That's not how Bitcoin transactions work. There's actually a reversed flow. She takes the first step. Whenever someone wants to receive money on Bitcoin, they've got to create a Bitcoin address, right? So they've got to say, generate new address, or open up the receive tab on their phone. And what it's doing, it's creating something called a locking script, which is a piece of text that tells Bob how to lock up his Bitcoins so that only she can access them. And she's got a little key over here that lets her unlock those coins. So she presents her locking script to Bob that is encoded in the Bitcoin address. He locks his Bitcoins to the coins in that Bitcoin address, which is actually a locking script. And then later, when she wants to spend them, she puts in her little key and unlocks it. And then the Bitcoins are free and she can spend them. And that's actually how Bitcoin transactions work: locking scripts and unlocking scripts. And both of them are made of text. Even here, I'm using an analogy with like a little lock icon and a little key, but these things are just text. And that's what we're going to use, is we're going to be manipulating text and writing when we write smart contracts. So how do we go from Bitcoin Script to smart contracts? Well, it starts a long time ago. Nick Szabo, who may be Satoshi Nakamoto, in 1996, he published a paper called Smart Contracts, and how you could do fancy cryptography stuff with money. And he said a smart contract is a set of promises specified in digital form. And then that part's simple enough. I get that. All contracts are promises, but these ones are digital ones. Makes sense? The second part is a little confusing: including protocols within which the parties perform on these promises. Nick used some strange grammar in this sentence. Another word for protocols, well, not another word for them, but protocols are implemented as software. And so what this is, another way of saying this is that the difference between a smart contract and a regular contract is that there's a piece of software that enforces a smart contract. A primitive ancestor of smart contracts is the humble vending machine. So in preparation for this, I actually did a little bit of research on vending machines. The ancient Greeks had them. There was an ancient Greek guy who made a vending machine for water, where it had a slot where you could put a coin in, and when you dropped the coin in, it would land on a little plate, which would fall a little bit, and it would open up a valve. And as the coin dropped on this plate, the plate would bend over, the coin would fall off, and then the plate would go back into place because of a spring, and then the valve would close. But they actually had water fountains that were coin activated, or vending machines, back in ancient Greece. And what's cool about a vending machine is that you have a sort of contract with whoever made the machine, which is like, I give you money and you give me chips or water or whatever the case is. But why these are an ancestor of smart contracts is that in this case, unlike a regular contract, no one has to be there to enforce the contract. It's sort of embedded into the hardware of the device. Like, you can embed a contract into a spring and a lever where the thing falls onto it and then the spring activates. And that causes the execution of the contract. But these days we can do the same thing with software. And so as vending machines kind of made contracts embedded into hardware, smart contracts make contracts embedded into software, where the software enforces it. Any questions at this point? Cool. Couple of examples of Bitcoin smart contracts. The simplest form of one, or at least I think it's the simplest, is a proof of purchase. What we do with Bitcoin is basically, this is another analogy I'm using. Putting in your Bitcoin into a locking script is kind of like putting it into a vending machine. And someone has to supply the right thing into the vending machine slot in order to get your Bitcoin to pop out. So That's sort of how smart contracts work. And in the case of a proof of purchase, the seller of a good has to supply you with a receipt, and they have to like put that receipt into this little slot, and that'll cause the Bitcoin to come out. So that they only get the Bitcoin you're paying them if they give you a receipt for the thing you're purchasing. Another thing you can do with Bitcoin smart contracts is create tokens. You can use this function in Bitcoin called op return to mark an address as special, and then you can treat the sats in that wallet differently. You can be like, these sats represent red coins, and if you send them around, someone gets 500 red coins or whatever. You can do swaps where you say you get X amount of coin A if and only if I get Y amount of coin B. This often uses this protocol where like they have to supply the private key to some coins on another chain, and if they give you the private key, then and only then do your Bitcoins pop out into their wallet. That's one way you can do that. Normally these days we use HTLCs on 2 chains to do it, but we'll get into that. The smart contract we're going to build today is a ballgame contract where you get a coin if someone trustworthy says, the Packers won, and I get a coin if they say the Saints won. So I'm representing that here. This little guy, he seems to know something about sports. He has got a Packers key and a Saints key, and he's going to give one of them to these guys after he knows who won the game. And then Alice over here, she's got the part of the smart contract says that if it's the Saints key, she gets to withdraw the money. But if he supplies the Packers key, then Bob gets to withdraw the money. So they've got some Bitcoins locked up waiting for him to reveal which key is going to do that. That's the one we're going to build today. Another thing you can do, not all things require a trustworthy person to give you information about the real world. If you do something like a lottery or a coin flip, you can do that directly in Bitcoin because Bitcoin can do random numbers. And then you can have you can have multiple parties to a contract, and one of them gets the money on a random basis. So that's something you can do. So I hope that these are some examples of things that I've built. Like I've built proof of purchase tokens, swaps. I've done ball games, lottery. I hope that you guys pick one of these or come up with your own. But I'm going to show you how to build a ball game contract. And then if you like that one, you can do that. Or if you like another one, you can make your own. Some of the functions that I frequently use when I'm writing Bitcoin scripts, the signature functions are very important, check sig and check multisig. We use those to ensure that only one person or only one of a set of people or a whole set of people can withdraw money from an address. There's password functions. Most people call these hashing functions because normal people are normal, and I'm weird, and I call hashing a password function. But basically, many people in here are going to be familiar with SHA-256. This is very commonly used by anyone writing software, really. It creates a fingerprint of a piece of data. And in Bitcoin, what we can do is you have to supply the data that hashes to this fingerprint in order to withdraw the money. And I think of that as like a password. You have to know the password in order to get the funds out of this address. We have time functions. We can set an absolute time and say you cannot withdraw this money until January 1st. We also have relative time. You can say you cannot withdraw this money until next week, whenever that happens to be. We have math functions, add, subtract, check if something's greater than a number, check if something's less than a number, check if something's equal to a number. I use those all the time, especially when I'm making stuff that involves random numbers. We have stack functions. Stacks are kind of like arrays in Bitcoin. If you're familiar with arrays in like JavaScript or Python, some of the things you can do with an array are like pop an item off the array. We do that with drop. Add an item onto the array. You can do that with dupe. You can rotate the array with rot. You can check how long the array is with depth. And that's really important because everything in Bitcoin goes on a stack. Everything goes into an array, and you have to deal with everything inside of one, which we'll get to in a minute. My favorite functions in Bitcoin are the Boolean functions. We've got and, or, and not are the built-in ones. You can compose NAND and NOR by combining and not or and not to get NAND or NOR. If anyone in here has ever built or taken a computer science class, the Boolean functions are all the they're the basis of circuit boards. The basis of every computer chip, like the computer chip in here, is just a sequence of they call them logic gates, which are like if this electron and this is on and this electron is not approaching, then that would be an or situation. But you can use the and or not the other Boolean functions inside Bitcoin script to construct complex logical constructs. So those are my favorite, and I think they're the most powerful tool for building Bitcoin scripts. We also have branching logic, if then else, verify and return. If then else, everyone who's programmed anything should be familiar with that. This is how you do just branching logic. If this is true, then do this thing, or if it's not, then do this other thing. We also have verify, where you can write a script path that only continues if the previous value returns true. So we do that with verify, otherwise the transaction fails. And then we have return, where if you encounter an op return in a Bitcoin script, it causes the transaction to fail. So you can use that if you don't go down this spend path, you can put an op return in there to make sure it doesn't happen. A full list of all the scripts that you can use when composing a Bitcoin script is available at this website. So this goes through in more detail, flow control, bitwise logic, all that stuff. And it gives you descriptions of what they do and some gotchas if you're trying to use them in your scripts. Very useful. A couple of gotchas that I want to mention. Unlike normal programming languages, in Bitcoin script, you cannot give custom names to your variables or your functions. So this makes kind of a headache when you're working with Bitcoin script, because you want to be like, I'm going to write a function called coinflip, and it's going to be function name coinflip, and it'll do this thing. Can't do that. You can write the function, but you just have to copy paste it where you want it to appear, because you can't give it a name and then call it later. Script compilers like bitcoinlib.js and Minsk are a workaround. They will give you a higher level programming language to work with that does have function names and variable names and things that we programmers are familiar with. And then they will turn that into Bitcoin script for you. But they're incomplete and finicky. So I usually end up working directly in Bitcoin script personally, but you can try these out. Minsk and Bitcoin lit. Well, I use this one all the time, actually. But you can try out Minsk, for example. I've never actually used it, but it is kind of neat that someone's trying to make a solution for that. You cannot write a function once and call it twice. So this is something that you frequently do in normal programming. You might write a function that compares two values, and then you call it anywhere where you want to do that. In Bitcoin, if you want to call a function twice, you've got to write it twice. You've got to put it in your script up here, and then if you want to call it later, put it again down here. Bitcoin script has support for integers and strings. Integers are max size of this, and everything above that is a string. So this is kind of a low value. That can be a gotcha if you're trying to do cryptography stuff. This is not going to be a high enough number, and you have to use other workarounds to get around it. Integers and strings must all be passed as hex, except for the numbers 0 through 16, which can be written as opcodes op0 through op16, because Satoshi put in special support for those specific numbers. Everything else has to be passed as a hex string. So those are some gotchas. Any questions about those or the built-in functions at this point? Okay, cool. Another gotcha is about if then else, which is weird in Bitcoin script. So in a normal programming language, this is how if else works. It's like, if this condition is true and this condition is true, then take this path, like check the signature on Al's pub key. Otherwise, check the signatures on Bob's pub key. And then you could specify anything you want as these conditions. Not how Bitcoin, you could even, in most programming languages, you can even specify other functions. Be like, if this function, run this function first, and if it returns true, then do this or do that. In Bitcoin, the only thing that can be passed to an if statement is a 1 or a 0. And also, you don't get to specify it after the if, like in a normal language. It has to come before. So the thing before this if has to be a 1, or it has to be a 0. And if it's a 0, it'll do this path. If it's a 1, it'll do this path. So that's how we do it in Bitcoin script. It is a little bit strange. Also, unlike normal ones, everything has to precede the function that you're calling on it. So in a normal language, you'd be like, check the signature of Alice, right? That seems normal. But in Bitcoin, it's like, here's Alice, check her signature. It's like Yoda speak. So that's how it works. Let's build one. You ready to make your first script? Let's do it. Get out your. I'm going to start by creating a new folder. I'm going to call this folder. How about script demo? Script demo, and I'm going to go in there and create a new file called index.html. As usual, when you're coding with Super, he does things ridiculously, and he does things directly in the browser. I don't usually use things like Node.js or frameworks or anything like a normal person. I'd code directly in the browser. So I'm going to open up that empty file, and I'm going to drop in it. Which one is it? Drop in it these contents. Paste, save, and now let's open up that file in the browser. Look at that, beautiful, gorgeous. I'm going to open up the console because we're going to be inspecting some stuff we're going to put in here. Everyone with me? You got a file opened up and you're ready to start coding in it? All right. Next thing is, there it is. Next thing we're going to do is import a couple of libraries. So I'm going to replace the head tag with these. And what do these libraries do? Well, this one is Bitcoin.js lib, and we're going to be using that as part of writing our script. This one called buffer lets us deal with large numbers because JavaScript, like Bitcoin script, has a limitation on number sizes. It can only go up to numbers that are 9 quadrillion, but public keys are way beyond that, and private keys are too, so we need a library to help us deal with bigger numbers. And then there's this library, variable unsigned integers for Bitcoin. This one is funky. When you're signing a Bitcoin script, you need to specify how long the script is, and it's a variable unsigned integer. And this thing, like this function, there's a function in this library that will like take our Bitcoin script, find out how long it is, and then prefix that number so you can sign it. But we'll get to that in a bit. Learn Bitcoin. Next thing we're going to do is we're going to create some public keys and private keys. I'm going to personally pop this into the body of my script or of my page. You can put it anywhere you want. But what's this going to do? It's going to create Alice. She's going to have a key pair, an elliptic curve pair of keys, private key and a public key. And it's going to give her a private key and a public key. And then we're going to log into our console Alice's public key. We're going to do the same thing with Bob and log his public key. And because we're going to do a ball game in this example, we're going to have two hashes, a Packers hash and a Saints hash. We're going to imagine that there's a ball game coming up between the Packers and the Saints, and the website of ESPN or whoever's reporting on the game says, like, this is the hash for if the Packers win, and this is the hash for if the Saints win. If the Packers win, we're going to reveal the pre-image or the secret or the password that this is a commitment to. And if the Saints win, we're going to reveal the secret that this is a commitment to. So we're going to make a password-based function where if they reveal this password, Alice is going to get to win. She's going to withdraw the money from the address. And if they reveal this one, Bob gets to withdraw the money. Everyone with me on what we're making? Cool. So let's save that, open up our browser, and check if there's any errors. And there are no errors. We have Alice's pub key and Bob's pub key. And that's all we told it to log. So that's all that's in there. Next thing, we are going to create the ballgame script. I'm going to pop that right into the body. And what does this ballgame script do? Well, this is the Bitcoin script here that actually specifies this contract. If we pass a 1 value to it, the 1 has to come before. We'll get to that part when we actually spend it. We're going to supply a 0 or a 1. So if Alice wins, she's going to supply a 1, and it's going to take the secret that was revealed for the Packers, and it's going to check if that secret, when hashed, matches the Packers hash, which is this one. And if it does, then that's great. She knows the secret that allows her to withdraw the money because ESPN or whoever revealed it to her. So we're going to check that those are equal to each other. And if they are, then we're going to put Alice's pub key on the stack and allow her to check her signature. It's going to check her signature and make sure that she's really Alice who's withdrawing. And that's it. And she can withdraw the money. Otherwise, if Bob won, then we're going to do the same thing. We're going to hash the secret he gives, check if it matches the Saint's hash, verify that, and then let him withdraw. That's the script. Does everyone see what we're doing here? Okay, cool. And of course, when you go to make your own script, you should don't use mine. You'll just replace this with whatever you write, and then you can make your own function that does whatever you want. Next thing we're going to do is call that script and make an address. So this calls the ballgame function that we just wrote, and it creates a pay-to-witness script hash Bitcoin address. That's a SegWit address that has that script embedded into it, and then it's going to log it to our console. So let's do that. I'm going to indent this so the indentation matches. Save, and let's view it. We should see a smart contract address. So this has the contract embedded into it that says Alice can withdraw if the Packers win, Bob can withdraw if the Saints win. Also, if we refresh the page, the address will change. A different address every time. And that is because the hashes are staying the same, but Alice and Bob's pub keys are changing every time because I didn't save them. It's just reloading them every time. So their pub keys are part of the smart contract. And so since their pub keys change, the smart contract changes. Everyone, that makes sense to everybody? Cool. Next thing we're going to do is, so we have the smart contract address. Let's pop that into Bitcoin and send some money into it. Go to Bitcoin Core, send some money into here. Of course, we're using the testnet, so it's not real money. But let's do 25 million sats is what they're going to be betting on. We'll do 1 sat per byte as our fee, and we're just going to send that. Oh, I forgot to give us some money. Of course, we need money. Create a new receive address. Copy this. We're going to mine a few blocks to give ourselves some money. How you do that, you open up window and go to your console. This is Bitcoin Core's console where you can control it on the command line. And we're going to generate coins to an address. I know this is hard to read. I can't make this part bigger. I can make this text bigger, but I can't make this part. We're running a function called generate to address. This gives us some free coins. We're going to generate 100 blocks, which is 5,000 coins, I think. And then we're going to deposit them into that address. I'm actually going to do 101 because I think there's a rule that you can only spend Bitcoins in Bitcoin Core after the 100th block passes. So I'm going to do 101 to make sure we can spend these coins. I'm going to deposit those into Bitcoin Core's address. My screen fills up with all the blocks. Look how rich we are. 50 Bitcoins, 50 Bitcoins, 50 Bitcoins. We're just mining like crazy here. Those will all go away in a second. And now we've got some money in our address, so I can use that money to send it into the address of the smart contract. So let's go to Bitcoin Core, send 25 million sats into there, and that's receive. 25 million sats, 1 sat per byte. Looks good. Bitcoin will make you wait 3 seconds to review your transaction before it'll send. And okay, we just sent that in there. The transaction has not been mined. You can see a little clock next to it. It's waiting to be mined. It's in the mempool. So why don't we go ahead and mine up another block just to get it mined. And now if we go back to the window, it's mined. There's a little block on top of it. That's cool. So we got some money into the address. Next thing we're going to do is spend it. Everyone ready to spend the money in the address? This means we have to decide who wins. Before we spend the money, though, we're going to have to put this function in, witness stack to script witness. What does this do? Well, this is something that Bitcoin.js needs. Earlier, I told you about that library we imported called variable unsigned integers. This whole thing uses that library to get the size of our script and then prepend the length of it so we can sign it. It's not something you really have to worry about. It's just you need it in your functions if you're using Bitcoin.js to write this stuff. So I'm just going to pop it into there because if we don't have it, then it'll fail because it doesn't know how long the script is. Paste it in, tab it over, save it. And now we are ready to spend our money. the spend transaction is kind of long, so I apologize for this, but it is a rather long script. It takes a number of inputs as well. So in order to withdraw from this address, we need the secret supplied by whoever's telling us the Packers won or the Saints won. We need the private key of Alice or Bob. We need to know Alice and Bob's pub key, as well as the hash of the Saints address and the Packers address, or not address, but the hash of their passwords. Because we need to recreate that address. In order to spend from the address, you have to recreate it. And all of these functions, the pub keys and the Saints, went into making that smart contract address. So we have to recreate it. Two other things we need. We need to know where the money is coming from when we spend this. It's coming from that address, right? The money's in that address, and we're going to spend it out of there and put it somewhere else. In order to specify which address it's in, you cannot just put the address in there because that address might have multiple coins in it. You need to specify. So what we do in Bitcoin, we take the transaction ID of the transaction that put money into that address, and we specify the transaction index. And let me just show you what that looks like. So let's go into Bitcoin again. We need to get the transaction ID. That's part of what we need. And I'm going to get the full transaction that sent money into our smart contract address. If you add false true afterwards, for those who are watching on YouTube and can't read this tiny print, the function we're running in Bitcoin is get transaction, then the transaction ID, which we got from the previous screen, and then we're adding the word false and the word true after it. What that'll do is it'll give us an output that you might see on like a block explorer if your block explorer was text only. It gives us lots of information about this transaction. In particular, we need the transaction ID. This is the transaction that sent money into our address. And then we need something called the transaction index, which is like the transaction sent money to two addresses. It sent 25 million sats into our smart contract address in index number 0 right here. And then in index number 1, it sent the remainder of the change, which was almost 50 Bitcoins, back to another address inside of Bitcoin Core. So this is the one we need. It's index number 0 and the TX ID. So we copy those, go back to here, replace the TX index with the one we just got, and TX index 0 happens to be the one that it does. Bitcoin Core randomly assigns a 0 or a 1 to your transactions, so you have to check and see which one it is. In this case, we got lucky, and it happened to be the one we already had in there from last time. We're also going to send the money out. So if Alice was running this, she would put her own Bitcoin address in here, and if Bob was running it, he'd put his own Bitcoin address. Here, I'm going to put the a Bitcoin address of that wallet that I created earlier, and that's where we're going to send the money to. We're going to specify that the amount of sats we're sending out of the address is 25 million sats, because that's how many is in there. We're going to subtract a fee of 500 from that, and that amount, 25 million sats minus 500, is what's going to end up in Alice's address or Bob's. So. Mm-hmm. How we had the flow was when I showed it from the beginning, we created a pub key for Alice, we created a pub key for Bob, we created the Bitcoin address, we put some money into that Bitcoin address. Now we're at the part where we're taking the money out of the address, because in the only one of them, only Alice or only Bob can take it out, depending on whether the Packers won or the Saints won. With me? Good. I know this is the hard part of programming. You get these random long strings that you got to do stuff with, and it can be a little unnerving for people who, well, for programmers as well. But so I'm actually, instead of going, if you go to my GitHub, this function is inside of the what's it called? Inside of the file that we create. But I'm going to actually put it in my console, and that way we can modify this stuff if we want to have a different person win. So, because if you put it inside of the file, instead, like, it becomes a constant, and we need some of this stuff to change. So I'm going to paste it into here, and then keep going with the next part of the script. This is a long one. The function to withdraw money from the address is more complex, and it has other parts. So what's this next part do? So like I said, we have to recreate that script address. So we pass the parameters to the script creation function. We specify that we're working on reg test. That'll give us our address, and now we know which address we're spending money out of. So we pop that into our script. Not over there. I'm doing it in here. Paste that. The next thing we do is this part. This creates a structure called a partially signed Bitcoin transaction. Partially signed Bitcoin transactions were created in order to make it easy for people to have multi-sigs, where you need multiple parties to sign a transaction before it's valid. We're not using a multi-sig in ours, but the PSBT format proved very useful for basically any kind of contract you're doing in Bitcoin. So people use it even if they don't have like multiple people who need to sign a thing. We still use the partially signed Bitcoin transaction format. So we're just going to copy paste it in and use it for our function. Not there. We're going to paste it here. And the next part of the script is the outputs. This adds an output to our PSBT. So it says we're spending from the address created using all of this data, and we're spending the money into either Alice's address or Bob's address, whichever one they put in. So that is where we're going to put the money. And then we sign it using the private key. We sign the whole transaction and say, all right, we know where we're sending money from, how much we're sending, and where we're sending it to. Let's sign all that using our private key. So we do that, pop it into our script right there. And I think we have one more page of function here. The getFinal scripts part, which this is where we supply the arguments that make our function true. Okay, so what does that mean? Earlier in this script, we created this script that says if Alice wins, or if the Packers won, Alice gets to withdraw, and if the Saints won, Bob gets to withdraw. When we spend the money, we need to trigger one of these conditions, because remember, op-if needs a 0 or a 1 to come before it. And we also need the secret. We need the secret that hashes to the Packers hash, or the secret that hashes to the Saints hash. So that's what we're going to supply down here in part 5 with getFinal scripts. We're going to push Alice's signature. We're going to push the secret given by ESPN or whoever that specifies whether the Saints win or the Packers win. And then we're going to have Alice win in this case. So we're going to supply op1, which will trigger that if condition. If we supplied op0 and the Packers secret and Bob's signature, then Bob would win. But in this example, I'm going to have Alice win. Does some of this make sense to people? I know it's a lot to go over, but that is the last part of our script. And then, so we go over here, paste it in, and hit enter. Good, no errors. That massive withdrawal function didn't give us any errors. Let's call it now. We're going to withdraw from the address, and here's the secret. The secret that says the Packers won the game is AB, 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 a whole bunch of ABs. That's what I made the secret. In a real situation, ESPN would not use such a dumb secret to specify who wins the game, but I made it easy so that I could have a fun, so I could make this joke. And then we're going to specify Alice's private key and the parameters we need to create the address, and supply all those to the withdrawal function. And what do we get out? We should get an error. Look at that. Witness stack to script witness is not defined. And I know why it's not defined, because I never saved it. I never saved this file and refreshed it when I added it in. So we're going to add it in right here and run it again. And now we get this little thing. This is a Bitcoin transaction. It takes all of the stuff that we just did and hexifies it, because Bitcoin only wants hexadecimal strings and numbers when we do stuff with it. So I'm going to copy this, go over to Bitcoin, and send it. Send raw transaction. Paste it in there. Of course, for people on YouTube, I know you can't read this. I used a function called send raw transaction, which is over here, and then I pasted the hex of the thing that we're sending. When I do that and hit enter, we get a transaction ID, which means it's successful. I'm also going to mine a block to make sure that makes it into the blockchain. And that was a success. Alice just withdrew the money from that address. If you wanted Bob to win, you could change the parameters so that when we do, where is it? So that when we call this, we would specify the other secret, the secret that lets the Packers win, that happens to be a C here instead of a B. That's the only difference between these two secrets. And then we would specify Bob's pub key, or private key, I mean, Bob's private key. And if we ran that, it would give us a Bitcoin transaction, but that would not be valid. And the reason why that's not valid is because we didn't specify a zero. A zero would trigger the else condition that lets Bob withdraw. And in order to put that zero in there, we would have to go up to this function and not this one, this function, withdraw from ballgame address, and change this last stack element from op1 to op0. And if we did that, Bob would have been able to withdraw the money. Of course, he can't now because the money's already been taken out by Alice. But yeah, that is, you've written your first Bitcoin script, and check it out. It was only like 100 lines of code. There's 60 lines here, and then an additional 40 from the withdrawal function. And that's it. You've made your own Bitcoin script. Any questions about what we just did? No, we're good? A couple. What's up, Austin? Okay. The reason why you're getting a missing input is likely because you copied my transaction ID and put that into your script to spend the money from this and then out again. If what you should do is take one from your own copy, from your own little testnet, and spend the money out of that address. Does that make sense? Is a possible explanation for the error? Okay. Topher, did you have a question? Mm-hmm. Yeah. Yeah. So to go over this for the people on YouTube, what happened? We had two people who ran into an error involving these two lines, and what they did was they either copied what I had here as my function, or they copied what I pasted earlier and used that into here. And that's natural because that's what I told them to do. But they shouldn't have done that. That never listened to Super. What they should have done is gotten those values from their own copy of Bitcoin QT, because I was sending money from an address that I created on my own local device, and that transaction that spent that money was only available on my own local device. So on their machines, they have to do this full step of procedures and put their own transaction ID and their own TX index in after checking what they are using the stuff I went over earlier. Yeah. And to be clear, which transaction ID, because there's multiple in a blockchain, it's the one that deposits money into the smart contract address. That's the transaction ID you want. And then the index number, if I go back to here, the one that deposited money into our address was this one, I think. Yeah. And index number 0 deposited 25 million sats into our address, which is this one, into our smart contract address. So you would want to use this one. Don't use index number 1 in this case, which just sent you your change back. So everyone with me now on why that happened? Okay, cool. So the next step, now that we've written our first Bitcoin smart contract, is for you to make your own. So one tool that I often use for writing scripts is Scriptwiz, which looks like this. And let me go over exactly what this is doing. There are a bunch of different panes on here. The one over here is the arguments to your script, and then this is the program itself. So in this program, what we're going to do is this one adds together whatever two values you supply as arguments and checks if they equal 3. So in order to do that, you have to supply a 1 and a 2 to do that. So over here on the right, this shows the state of the virtual machine. At the first line, the first thing that happens is somebody deposited a 1 into the stack, onto the array. And so the stack just shows you that there's a 1 on it. In the next step, they deposited a 2. And so it puts that 2 right next to it, right next to the 1. And then down here, when we run the program, we add them together. So it takes the 1 and the 2 as input and deposits a 3 onto the stack, because that's what happens when you add 1 and 2 together. You get a 3. Then we're going to check if they equal 3 by adding another 3. So there's 2 3s right next to each other. And then we do op equal to see if these two values are identical. And if they are, it deposits a 1, which is a true. You might use that to trigger an if statement, like if they supplied numbers that add together to 3, then let them withdraw the money, or otherwise don't. You could do that for like an algebra thing. You could put algebra into your Bitcoin contract. But yeah, this one nice thing about working with an IDE like this is it shows you what functions you have available. And then you can go and play around and make a program that does whatever it is you want. And once you have your program ready, you can copy whatever's over here and replace what I did earlier in one of these slides. I think it was this one. You can replace the script here with the output of whatever the Scriptwiz IDE gave you, and then run your program and actually deposit money into your smart contract and then take it out again. So that's kind of fun. One gotcha as well when you're using Bitcoin Script wants variables to be put in this format, and Scriptwiz does not. When you put in a hash of something in Scriptwiz, it goes like this. Scriptwiz wants variables to be put in this format, and in Bitcoin Script, it wants them to be put in like that instead. So it's a little bit different syntax because these are two different programming environments. You have to convert between them. But yeah, if you're going to use variables and stuff, that's how you have to modify them when you put them into Bitcoin.js. And then Bitcoin.js will give you output. Everyone good? You ready to write your own stuff? Let's do it. Get to it. And I will be available for questions if anyone needs help writing their first program. I am here to help you. That's the end of the presentation. These are some references if you want to look more into where I got some of this stuff. Nick Szabo's 1996 article on smart contracts was important for describing what they are and how they work. Andreas Antonopoulos' 2014 book, Mastering Bitcoin, goes over how the script engine works. And he also he made a video that's kind of similar to this one, where he like goes through and writes a contract with you. He did that in 2017. It's called Advanced Bitcoin Scripting. I used that in preparation of this talk. And the Bitcoin Wiki has a script article that goes over all the functions and gives you helpful hints. There's this whole section that I wrote. I wrote this whole section where I was going to show how the stack operates and how you take things from your arguments and you operate on them using your program, and then how things get taken off the script and added into it. But I decided not to do that because of reasons. So that is there if you want to go over how the script works. It's in the slideshow, but that's the end of my presentation. Thank you guys for watching and listening.